Welcome to the DIY Honda Garage channel. DTC P26F2 specifically denotes an issue with the starter cut relay diagnosis circuit in the Honda Civic 2022 model and later. This diagnostic trouble code indicates that the voltage on the input line connected to the starter cut relay is lower than a predefined threshold when the starter is not engaged. The Powertrain Control Module, or PCM, detects this anomaly and consequently stores this fault code. The purpose of the starter cut relay is to prevent unauthorized starting of the engine, enhancing overall vehicle security. Its correct functionality is crucial for proper engine operation, especially during the starting process. When troubleshooting this DTC, it is important to ensure that the entire circuit is functioning as expected to avoid unnecessary component replacements. The starter cut relay plays a key role in vehicle security and starting efficiency by preventing unauthorized ignition of the engine. The PCM uses this relay to monitor operational parameters, ensuring that everything is within specification before starting the engine. Should the input voltage drop below a defined specification, the PCM flags this condition as an abnormality, leading to the storage of DTC P26F2. The relay circuit board houses essential components responsible for this monitoring function. Specifically, you'll find the starter cut relay positioned within the vehicle's electrical system, making it a critical focus during diagnostics. Understanding the precise location and function of these components is vital for effective troubleshooting. Several factors could contribute to the triggering of DTC P26F2. A faulty relay circuit board can disrupt the overall functioning of the starter cut relay, leading to voltage issues. Next, an external circuit short can also compromise the integrity of the signal that the PCM expects. If the PCM, which stands for Powertrain Control Module, itself is malfunctioning, this may lead to erroneous voltage readings. It's essential to inspect wiring thoroughly, since damaged or shorted wires can prevent the relay from operating correctly. Lastly, improper signal detection by the PCM can result from various failures within the circuit, making comprehensive inspections crucial. Drivers may experience several symptoms associated with DTC P26F2. Commonly, the engine may fail to start altogether due to problems in the starter cut relay circuit. In some cases, it might exhibit intermittent starting issues, where the engine starts sometimes but not others. A no-crank condition can also arise, where the vehicle does not respond when the ignition is turned. Moreover, dashboard warning lights may illuminate, alerting the driver to potential malfunctions. Finally, the presence of this and possibly other error codes can indicate that further diagnostics and repairs are necessary, emphasizing the interconnected nature of automotive electrical systems. The first step in troubleshooting DTC P26F2 involves attempting to start the vehicle. This initial action helps confirm the symptoms being experienced. After the attempt, turn the vehicle to the off or lock position, which essentially resets the network and prepares the system for diagnostics. Following this, switch the vehicle back to the on mode and wait for about 5 seconds. This waiting period allows the PCM to gather relevant data and stabilize its readings. Lastly, confirm whether the DTC is still present after performing these actions, ensuring that all conditions are thoroughly evaluated. The second step in the troubleshooting process focuses on testing the relay circuit board, particularly the starter cut relay 2 circuit. Begin this process by carefully following the inspection outline provided. This typically involves checking specific components indicated by dotted lines in the diagnostic manual. It's essential to inspect each item methodically to ensure every potential failure point is evaluated. Document any anomalies found during this inspection, as they will be important for making informed decisions about repairs. When testing is completed, the results will guide the next steps in accurately diagnosing the issue. For the third step, attention turns to inspecting the external circuitry linked to the starter cut relay. Here, the primary objective is to identify any shorts in the wiring that could impede proper function. Verification of the circuit's integrity is essential. A broken or frayed wire could lead to low voltage conditions that spark DTC P26F2. Additionally, it's critical to closely examine connections to the PCM to ensure proper signal transmission and functionality. Keep meticulous records of your findings, as these will be crucial for both diagnosis and necessary repairs, assisting in isolating the root cause. The fourth step involves conducting a comprehensive inspection of the PCM itself. Review the outcomes from the previously completed troubleshooting steps to assess the integrity of components and connections. Determining the status of the PCM requires careful verification, as it may itself be the source of the trouble code if all other items are functioning correctly. It's essential to check for any circuit faults that might indicate damages or failures within the PCM system. Once inspected, report the symptoms and findings accurately to ensure that all information is available for making repair decisions moving forward. Upon completion of repairs for DTC P26F2, it becomes imperative to perform a final repair verification. This involves clearing any stored diagnostic trouble codes, DTCs, from the PCM to reset the system. Subsequently, retest the various system functions associated with the starter cut relay circuit to ensure everything operates normally. One critical aspect of verification is confirming that the voltage returns to acceptable levels, ensuring proper relay operation. Documentation of the repair results is also essential for future reference, as it enables a record of actions taken and outcomes achieved, fostering ongoing accountability in vehicle maintenance. Preventive maintenance is crucial for avoiding issues such as DTC P26F2 in the future. Regular inspections of the vehicle's electrical systems help catch potential problems before they lead to significant failures. Paying attention to the quality of electrical connections can prevent becoming loose or corroded, which often contributes to starting issues. Monitoring the health of the vehicle's battery is equally important, as a weak battery can impact relay operation. Keeping all connections clean ensures reliable functionality of components such as relays and wiring. Lastly, proactively replacing worn components, particularly in the relay circuit, can save time and resources while keeping the vehicle in optimal condition. In conclusion, DTC P26F2 indicates specific voltage-related issues within the starter cut relay diagnostics circuit. Troubleshooting this problem effectively necessitates checking the entire starter cut relay circuit, including the PCM, to identify malfunctions accurately. A methodical approach with thorough inspections of all components involved will yield the best results in diagnosing and resolving the issue. Since the PCM plays a critical role in voltage monitoring and system operation, its functionality must be verified alongside surrounding circuitry. Finally, documenting each troubleshooting step and outcome will contribute valuable insight for future repairs and system maintenance. Please like and subscribe to the channel. See you next time.